Alrighty, the attendees list is slowing down a bit, so I think we're good to get started. Hi, everybody. Thanks again for joining us for the last installation of the Data for Decision Making, Offshore Wind Energy Areas and Geoscience Survey Results workshop series. My name is Claire Kleinknecht. For those that don't know me, I'm the Research and Engagement Officer with Marine Renewables Canada, and I'll be helping host the session today. Marine Renewables Canada is really excited to be partnering with an excellent team of research scientists from the Geological Survey of Canada for this workshop series, covering geoscience survey results from all three wind energy areas included in the current call for bids process. So these are Middlebank, French Bank, and Sydney Bight, which will be the focus of today's session. If folks are interested in Middlebank and French Bank and might have missed our sessions earlier in the week, these will all be uploaded to the MRC webpage by the end of next week in video format for review and distribution for those that weren't able to make it. Um, if any folks online are new to our organization, MRC is the National Industry Association for Offshore Wind, Tidal, Wave, and River Current Energy, and our goal is to champion Canada's growing marine renewable energy sector through advocacy, engagement, and education. Key to our education work has been our webinar series called Ask an Expert, which explores Canadians' biggest questions related to offshore wind, sort of looking at lessons learned from other jurisdictions, but we're excited to be expanding our programming with this new Data for Decision Making series designed to connect subject matter experts with those who need data to plan and participate in the growing renewable energy sector. Now, I'd like to take a moment to recognize and acknowledge the traditional territories and Indigenous peoples of the different lands that we are all on today. I'm hosting this webinar from Mi'kma'ki, the unceded ancestral territory of the Mi'kmaq people. Given that we're coming together today to discuss offshore wind, I'd also invite us all to think about the impacts that marine renewable energy can have on Indigenous communities and how we can improve our own understanding of local Indigenous peoples and their cultures to ensure that MRE projects move forward inclusively and respectfully. Now, before turning it over to our expert guest today, a few housekeeping notes. We will be recording this webinar, as I'd mentioned, that'll be posted to the MRC's website and YouTube page. However, the recording is going to stop at the end of the presentation to allow for a more open conversation during the discussion period. Today's workshop will begin with a long presentation, as I mentioned, followed by a discussion period. We really want to get through as many questions as possible, as that's the intention, is to connect you with the foremost experts in the field. So I encourage you to ask anything that comes to mind. As the presentation's ongoing, feel free to open the Q&A tab and you can start submitting questions at any time. And then I will begin the Q&A session following the presentation, as I had mentioned. But uh, can folks hear me? Yeah, okay, great. Now, I would like to introduce today's speaker, Lynn Defoe. Lynn is a research scientist with the Geological Survey of Canada at Natural Resources Canada, and her work focuses on onshore and offshore sedimentary basin analysis in support of the energy and minerals sectors. She is currently leading the bedrock component of the Geological Survey of Canada's Marine Renewables Program, which aims to develop a regional understanding of the nature and distribution of bedrock at the seabed and beneath quaternary cover to support future offshore wind development. Today, she's going to provide an overview of what geoscience data exists, how it's collected, key findings, and ongoing research in the Sydney Bight WEA. Thanks, Lynn, for joining us, and please take it away.
Great, thanks, Claire. Second here to share. Can you see the presentation?
Yep, I can see it here. Thanks, Lynn.
All right, my laser pointer as well. All right, thanks, Claire, for introducing the webinar today, as well as hosting the webinar today, and as well as the last 2 days. So I'm be presenting data for decision making for offshore wind and focusing on Sydney Bight. So just an outline here. I'm going to start with a few words about the Geological Survey of Canada, in case you're not familiar, and then just describe our marine renewables program, and then also talk a little bit about just sort of general GSC data and sample availability. And then we'll focus in on the Sydney Bight data that's been collected and our preliminary results to date, and then wrap up with a summary. All right, so the Geological Survey of Canada, we are a large government organization. We do geoscience across the Canadian landmass as well as in the offshore. And we have more than 500 staff supporting this work within 8 divisions and 8 offices across the country. And so here we are in the Atlantic office, where we also have our GSC UNCLOS office. And we have more than 45 specialized laboratories across our offices. And so our mission or mandate is to provide geoscience knowledge to inform decision making. So this is for the mineral and energy sectors, also effective environmental stewardship, wise land use, and safety and security of Canadians. So, and this applies to offshore wind development. So we are here to provide geoscience knowledge for decision making for other federal and provincial governments as well as industry, but we're not here to select sites for wind energy development or provide sort of the detail needed necessarily for site selection. In terms of marine geoscience with the GSC, we have 2 locations. The first location here, the Bedford Institute of Oceanography in Dartmouth, Nova Scotia, where I'm at. And we have the Institute of Ocean Sciences in Sydney, BC. And between these 2 offices, we have active research in the Arctic, Pacific, and Atlantic Oceans. And we also do close collaborations with other government departments, such as Department of Fisheries and Oceans, as well as universities and stakeholders. And our science focuses on what we call programs within several themes, including sustainable development and public safety, offshore natural resources such as offshore wind, and ocean governance, which would be related to our UNCLOS program. So our marine renewables program is funded under the Offshore Wind Pre-Development Program, and within that, the Atlantic Canada Offshore Wind Marine Data Collections Campaign. This started funding with the budget 2023. And we also have funding under the Energy Innovation Program through OERD, which also started in 2023. And we also collaborate with the Marine Geoscience for Marine Spatial Planning 2 program, also started in 2023. So to note here that we are at the end of year 3 within a 5-year program for all of this work. So really, we're still in the early stages, and the results we'll see today are preliminary. So as I'm sure you're familiar, offshore wind farms have many components. These are installed both on and into the seabed. So it's not just the turbines, there's cables and cable landfalls, and all of this development requires geoscience information. And the most significant information are things like water depths, understanding of seabed sediments and surface geology, also the subsurface sediments and bedrock, engineering characteristics, sediment mobility, hazards, underwater landslides, whether there's presence of gas and subsurface salt, as well as anthropogenic features such as the shipwreck here. So an example here off of Picto showing complex bathymetry with various bed forms, and an example here just showing sort of complex subsurface geology with various quaternary units in brown and green, and bedrock lying underneath in pink. So to provide information on those various key geoscience data sets, we have developed various initiatives under our Marine Renewables program. So we have geohazards and geoconstraints. These are led by Pierre-Arnaud Desiage, and he spoke 2 days ago on the Middlebank area. Then we have Calvin Campbell, who presented yesterday on the French Bank wind energy area, and he's leading quaternary sediments. We have surficial geology led by Geneviève Philibert, geotechnical properties led by Jordan Emer, who's also our project leader for Nova Scotia. And then we have Michael Lee leading sediment mobility and myself leading the bedrock study. As well, we have Natalie Shea as our program manager.
So the work we're doing under these initiatives and that you'll see today are going to be released. These preliminary results will be released in a report either at the end of March or likely into April, and basically just summarizing the work to date, data collection, various resources and reference that will be useful for industry to develop. And we also have a coincident limited data release on our geo.ca platform. Includes multi-beam, backscatter, sub-bottom profiling data, and station information, again to be released likely within April. And this is data specifically from some of the more recent cruises. So I just want to focus a little bit on GSC data and samples that are available in case you're not familiar. We have an expedition database. So here's the URL link. It's a public-facing site where you can access cruise reports, station data, and seismic data. So you can see on the Google Earth image down here, various seismic track plots and station information, and as well analytical results. And information is uploaded to these or to the expedition database as it becomes available. We also have a repository where we have both ambient and cold core storage. We house our sediment samples, bedrock samples. You'll see some of these materials highlighted in the presentation today, as well as archival and paper records that include information on positioning and sample data, which is particularly important, especially for some of the more legacy expeditions. Sediment core analyses are also part of what we do in the labs. We have several instruments. So we have X-ray computed tomography. This does 2D X-rays as well as 3D reconstructions, as well as laminography. And we have multi-sensor core loggers that do both whole cores. You see in the video here, they're doing on board one of the vessels, as well as split cores. This includes photography, bulk density, magnetic susceptibility, P-wave velocity. And we also have a micro XRF instrument in our labs. We also take shear vane measurements down cores, acoustic velocity measurements. We take subsamples and do grain size analyses on those. And we also send out analyses to be done externally, so X-ray diffraction and carbon-14 dating to provide age profiling for the cores. And we've done significant active data collection since 2023. There's been 12 expeditions. That includes hundreds of stations, so samples like Van Veen grabs, photo stations, like this middle bank image here showing this firm clay unit at the seabed, moorings, as well as tens of thousands of kilometers of sub-bottom data. So example here from French Bank, and hundreds of thousands of hectares of new mapping. So this is multi-beam and coincident backscatter, as well as mooring and lander deployments that have been done primarily in conjunction with DFO. Okay, so we're going to focus on the Sydney Bight wind energy area. And we'll start with superficial geology. So the work that's being done in general under this initiative includes understanding of regional sedimentation, geomorphology, and also semi-automated mapping. So for the Sydney Bight area, there was significant multi-beam data collected in 2024 and 2025, including this grid. And there's about 40% of the wind energy area covered, and we have equivalent backscatter coverage for the area. There's also additional existing nearshore coverage. You'll see some of that in some of the other slides. So fairly extensive multi-beam coverage overall for the Sydney Bight wind energy area. However, for the superficial geology, the current state of what we have is a broad overview map that was done by Philibert et al. In 2024. So this is their regional map. It's an open file, so it's accessible. But if you zoom in on the Sydney Bight area, you can see the wind energy area is dominated by post-glacial sand and gravel and late glacial sublittoral and sand. So effectively, the map showing it's dominated by a single surficial geology unit. However, based on the data that we've recently collected, we know this is not the case. There's a fair bit of variability. And so what they're going to be focusing on in the coming years leading up to the end of the program is a detailed surficial geology map for the Sydney Bight area. And this will include that newly acquired data, multi-beam, backscatter, high-resolution seismic, and seabed samples and images. So some of the preliminary results, as I mentioned, the new multi-beam bathymetry and sample data shows that there's a lot of variability. So we have this station A here in the northeastern part of the wind energy area. We can see sediment waves on the seabed, and in the photo station, we can see sand with sand dollars. Versus in B and C here in the southern part of the wind energy area, we can see this rough terrain on the seabed that's indicating a lot of bedrock exposure. As we can see in C here, this bedrock ledge with a diamict on top, and then other places where we see diamict on the seabed itself. And this seems to be fairly common for the southern part of the wind energy area. So again, more detailed mapping to come. There was also a geological model for infrastructure compiled by Jean-Yves Philibert and colleagues. Again, quite regional scale. So this was done to provide insight into what potential foundations would be possible. So here is pile and caisson. Information that was used include water depth, superficial geology, sediment thickness, slopes, sediment mobility, etc. However, again, noting that the superficial geology that was used for these maps was the broad scale information. So again, more detail to come to improve our understanding of what might be possible. But this is an open file, so and here's the DOI link. Okay, so we'll move on to sediment mobility. And so the work, again, in general that's being done under this includes bank scale modeling, looking at geomorphology, deployment of moorings and landers, and I'll also talk about benthic habitat under this section. So there haven't been any mooring or lander data collected yet. There were some deployments, but that was primarily for DFO priorities. However, we do have a model developed. This includes high resolution wave, current, and sediment transport. Here's the regional model. You can see the coverage. At that scale, it was 3 to 5 kilometer resolution. But for the wind energy areas, including Sydney Bight, they have a much higher resolution at 200 to 500 meters. And you can see the mesh of data used. This is for emerald and sable banks as an example. And so wave height for Sydney Bight wind energy area, you can see it's increasing offshore to somewhere close to 2 meters. And the mean wave period generally seems to be somewhere between the 7.5 and 8 second for much of the wind energy area. And these data are really important to understand sediment mobility at the seabed and how that might impact potential installations. For benthic habitat, this has been opportunistic study of newly acquired data from both ROV and photo transects. And we've identified 3 generalized habitats. So the first one in nearshore settings in about 20 to 30 meters water depth, where we have bedrock and gravel dominating. We see primarily algae. At the intermediate depth rocky settings, so in the 50 to 60 meters, so kind of within the central part of the wind energy area, we have again bedrock and gravel with thin sediment veneer. And here we have generally low abundance and diversity with some potentially sensitive jellyfish that were identified just from the photos. And then finally, a sandier deep water setting. So that's in the northeastern part of the wind energy area here, where we see bioturbated sands with sand dollars, brittle stars, and polychaetes. Okay, so we're going to move into the subsurface, looking at quaternary sediments. So the work that's being done under this initiative includes isopac mapping, developing geological cross-sections, and assessment of tunnel valleys. So some of the key data required for this part of the program includes sub-bottom and shallow seismic data. So we have our air gun or sparker system. This provides about a 0.5 meter resolution. And we have the Geoforce or Huntec deep-towed sparker or boomer systems. These provide about a 0.1 meter resolution. It's an example here of a line from Sydney Bight. And then we have the hull-mounted sub-bottom profiler, again, with about a 0.1 meter resolution. In terms of coverage, this shows the legacy data in the area. So it was fairly sparse, mostly from the 70s and early 80s, with generally poor imaging of the subsurface. So with that in mind, in 2024, Calvin collected a grid of deep-towed sparker data in the black lines here, so we have fairly good coverage. This also includes in the white solid lines, the Knudsen hull-mounted sub-bottom profiler data, and in the dashed white lines, Kongsberg hull-mounted sub-bottom profiler data, which is slightly higher resolution or better than the Knudsen data. So fairly good coverage for the Sydney Bight wind energy area. In terms of the Quaternary stratigraphy history for the area, this area experienced at least 6 distinct phases of glaciation since about 75,000 years ago. It was completely glaciated during the last glacial maximum, with ice retreating along the Laurentian Channel around 14,000 years ago. And this resulted in subsequent re-advance and flow along other secondary channels like the Cape Breton Channel, which is nearby here. And then from the last glacial maximum until about 13,500 years ago, the area was subglacial, then became emergent around 9,000 years ago. However, there's been no studies of the Quaternary stratigraphy for the Sydney Bight bank area. In 1999, there was Geoscience and Lehman did some work in the Laurentian Channel here, and they developed this stratigraphy, which was well dated with that middle till being 13,500 years old. And that can be correlated onto line B here. So that's the middle till here, where it comes up and appears to thin on the top of Sydney Bight Bank. And then this line here, C here, that goes across the Ingonish Channel and up onto the bank. So this is across the channel and onto the bank here. Has a very standard glacial moraine succession. So we have bedrock, ice contact till unit, ice proximal unit, and then glacial moraine and post-glacial deposits. However, as you can see here, it's very difficult to actually correlate those units up onto the bank. And we don't have any ground truth information on the bank itself from piston or gravity cores to really understand the age and the nature of the units there. So here's an isopac map of the quaternary sediments on the bank itself and within the wind energy area. So we can see the dark blues indicate thicker sediments, and the white or light blues indicate very thin or absent quaternary sediments. And in general, there's less than 5 meters of sediment cover over much of the wind energy area, with bedrock being fairly exposed in this red dashed area. So we have 2 profiles here, A from southwest to northeast, showing quaternary sediment in yellow with bedrock in gray. You see how thin it is, especially in the southern part of the wind energy area. And then profile B here from the northwest to southeast, showing thickening of quaternary sediment as we go to the east. Excuse me for a sec. All right, and profile C As it reaches the northeastern part of the wind energy area, we see these stacked units that are interpreted as till deposits, with these channels likely being possible tunnel valleys, and these are linking in with the Laurentian channel off to the northeast. And then finally, profile D. We can see some of the character here with these dune features that are several meters in scale on the seabed, and overlying our exposed bedrock. So we can see this rough terrain here being exposed bedrock at the seabed. Okay, next we'll move on to geohazards and geoconstraints. And the work that's being done under this initiative includes a study of bank edge processes, density flows, glauconite, and boulders. And for this presentation, we'll focus on the glauconite and boulders. So a significant part of the work that they're doing under this initiative involves quality control of legacy grain size data. So looking at the accuracy of the analyses and the parameters and how that compares to how we collect grain size data with modern techniques. Also looking at the accuracy of coordinates, as many of the early expeditions in the 60s and 70s had poor control over their location, and also looking at metadata and digitization of older metadata that might not be in our expedition database, and also resolving things like multiple entries for the same stations where they have different grain size information for the same station and what that particularly means. And so Pirano and his team have been analyzing old samples with new techniques, with this graph here just showing the percent difference between 1970s and 2025 analyses, with the silt fraction showing 50% difference and the clay fraction notably showing 100% difference. Sorry, I'm losing my voice a little bit here. So other important information for understanding the geoconstraints are collecting sediment cores. We have 2 cores that were collected in the Ingonish Channel where the sediments are thicker. Again, because the sediments are so thin on the bank area and within the wind energy area, it's difficult to collect gravity and piston cores. However, we may have potential to collect vibrocores in future. The other component that's of interest is the free fall cone penetrometer testing. We have one station that's in the southwestern part of the wind energy area, and this provides information on pore pressure, shear strength, and sediment behavior. Some of the other new data that we've collected includes more than 50 Van Veen grab samples. So this example of a Van Veen here, with 26 of those within the wind energy area, and 24 IKU grab samples. So this is the larger grab sample device, with 17 of those collected in the wind energy area. We have photos and subsamples of those grab samples, and are also studying the drop camera transects that were deployed with some of those collected as well. And we're doing grain size analyses of all subsamples. This includes the 0.04 micron to 32 millimeter fraction. We have 2 instruments for that, the laser counter on wet sediment and the cam sizer on dry sediment. This work is in progress, as well as the quality control of the legacy grain size data. Also doing visual analysis of sample photos as they were collected on the ship, and XRD and XRF analyses on selected subsamples. So this provides information on mineralogy, so the glauconite we'll talk about shortly, as well as elemental compositions. and then a visual analysis of drop cam photos. So this is used for the habitat mapping that we previously saw, as well as boulder identification. So we see these large clasts. This is 10 centimeters on the seabed. So boulders are definitely a geo-constraint within the Sydney Bight wind energy area. We can see all the stations here in red show indications of boulders at the seabed. Um, this is everything from 20 centimeters and up, so effectively a large cobble size and larger. However, they haven't identified any boulders larger than 1 meter at this time. And there's two distinct environments. So there's exposed bedrock, where we might collect large bedrock samples with our IKU. And then there's also areas with potential diamect, where there's large cobbles and boulders mixed with silty sand and gravels as well. The next step of this part of the project is to identify or see if it's possible to identify boulders on multi-beam echo sounder data, both in the depth and backscatter. Glauconite is also a concern in terms of wind energy development. So this is definitely a concern in some of the European wind farms, as well as offshore eastern United States. This is a dark green iron-rich phyllosilicate mineral. And the problem is its crushability results in sort of a high resistance or friction when doing things like pile driving. And thus far, we've only identified glauconite in the English Channel area. So this the orange dots on the map here, primarily because we don't have sufficient samples from the wind energy area itself that have enough of the finer grain fraction to do the analyses on. Within those stations, though, there's about 0.1 to 3.1% glauconite in the mineral assemblage, so fairly minor component. And the next steps of this project are to do analyses of the sediment cores to understand if there's glauconite in the subsurface as well, or is it just restricted to the seabed? And then also understanding whether glauconite is allochthonous, so whether it's being brought in from another environment and transported, or whether it's autochthonous and developing in situ. And this can be assessed by maturity. So the darker the glauconite grains, the more mature they are, as well as the more rounded, and also detailed SEM EDS analysis. So this is a glauconite grain, so this is like effectively a sand grain, and this is its elemental composition from EDS. Okay, so next we'll talk about geotechnical properties. So the work they're doing under this initiative includes building a database, looking at soil behavior, and organic low stand deposits. However, for the Sydney Bight area, again, the minimal sediment cover, as you can see in the video, means that it's more difficult to collect geotechnical information. So that one FFCPT station actually yielded no data. However, the geomechanical lab here at the Geological Survey of Canada Atlantic office will begin testing reconstituted sand samples from grabs, and that will provide information on strength characteristics using triaxial and bender testing. And we've also been doing geotechnical testing of bedrock samples, including porosity and tensile strength from select samples. And we also have some in-house capabilities with point load tester and rock Schmidt hammer as well. So finally, bedrock. Under this part of the work, we're identifying the basal unconformity, so just the boundary between the quaternary and bedrock, looking at bedrock distribution and character, as well as developing a subcrop map. So my colleague Ned King has been looking at sort of the surface geology and is focused mostly in the nearshore. As I mentioned, we don't have a detailed surface geology map for the wind energy area at this time, but he's identified bedrock and In particular, noting the shallow meandering channels in the Carboniferous bedrock in the nearshore area that could provide potential conduits for cable landfall. So just some context in terms of the bedrock. The Carboniferous Sydney Basin, which is highlighted in red on this map here, in the onshore. This extends offshore well into the Laurentian Channel, and this is based on well and seismic data. This is well known, as well as the onshore mapping is well established with northeast-southwest folds. And the units that we're most interested in for offshore wind are the ones that are near surface. These form the units that are subcropping below our quaternary sediment, and this includes the Pennsylvanian to Permian Moraine and Pictou groups. And these are continental siliciclastic deposits, so ancient fluvial and floodplain type deposits. So there was no historical seabed samples of bedrock, but we were able to collect 11 new grab sample stations. Those are the dots in yellow on the map here, and some examples here. And we collected various sandstones and siltstones from these stations. We also have data from the North Sydney wells. So these are the F24 and PO5 wells, as well as shallow nearshore boreholes, also shown in white dots on the map here. We've also used the multi-beam bathymetry and shallow seismic, as we've seen earlier in the presentation, and tying in with the onshore geology. So the Moraine group onshore here with the corresponding anticlines mapped in red and synclines mapped in blue. In terms of well data, the North Sydney wells contain Pictou group red beds below casing points where you pick the Pictou group to Moraine group transition varies, but we're using this unpublished work by Peter Giles. But the main point here is that at around 300 to 400 meters below the seabed, we have Pictou group, and that unit likely extends to the seabed, whereas we have Moraine group on shore. So at some point, we're transitioning from the Moraine group to the Pictou group beneath the seabed, and that will form part of our subcrop map. So we saw this map and profiles earlier. Again, generally thin quaternary sediment cover, and this actually allows us to map some of the features and structures within the bedrock. Normally, this would require air gun or industry seismic data, but we can use our shallow seismic here just because the quaternary cover is quite thin. And we can use this to map where we see anticlines and synclines. And here I've just traced some of the major fold structures. And so we can actually extrapolate what we see onshore into the offshore. There's a bit of a data gap in between here where we have less information, but based on the more major structures, we can trace them offshore as these northeast plunging fold structures. And there's several smaller folds as well that add to the complexity. I'm just showing the major structures here. And the bedrock character that we can see in the multi-beam swaths as well as the grid of multi-beam data actually allow us to confirm dip directions and map the fold structures more cohesively. And I'll just focus in on this more nearshore part of the area, just to show again sort of this bedrock character in the nearshore. It's very much exposed. But what's interesting in terms of the sample data is that these stations seem to be consistent with Moraine group, brownish gray sandstones and siltstones, whereas from station 214 here we have red sandstones. So possibly this interesting bathymetric feature here might correspond to a transition from the Moraine to Pictou group and are part of our subcrop map. So just summarize the presentation. So we saw that detailed superficial geology mapping is ongoing. This will help better constrain the character of the seabed in the area. We have models of wave, current, and sediment transport for sediment mobility. We have 3 general benthic habitats that were identified. Geoconstraints definitely include boulders at the seabed, as well as minor glauconite, for sure in the Ingonish Channel, with more work to come there. Quaternary sediment cover is generally thin on the bank and thickens to the east and northeast, where till is likely present. And geotechnical study of sediment samples is ongoing, but again, limited by the lack of sediment cover. We have detailed shallow geology from the coastline to about 10 kilometers outboard, just showing bedrock units. And within the subsurface, we can map bedrock in northeast plunging folds with a potential pictogroup subcrop edge mapped. And I'll just mention that we have our leads on the various initiatives, but there are several staff at the GSC Atlantic office that are involved with this project, as well as other GSC offices and academic and other partners involved with the work. And just to acknowledge the captain, crew, and science staff for the various cruises, CHS, our geoinformatics and marine engineering and technical support groups here, as well as our lab and collection staff, the Ocean Engineering and Technology section at DFO, and our MGMSP manager, Ian Dark. And that's it.